Brought to you by the National University of Singapore in celebration of SG50.
A smart and green city by 2030. That's the vision of Singapore. And its government is investing heavily in science and engineering research to reach this goal. The world's quest for sustainable living requires researchers everywhere to tackle transportation, energy consumption, and food security challenges head-on. In the last decade, Singapore has developed solutions that benefit people within and beyond its shores. It comes in many forms, feeds more than 4 billion people, grown in more than 150 million hectares of the world's arable land. Rice, one of our oldest food sources, and it's now increasingly under threat.
Rice crop yield is facing serious constraints because of the global climate change. So these include increased susceptibility to diseases and decline in land area for cultivation, as well as water scarcity. Therefore, any efforts towards addressing food security for the region would require that we improve the rice crop.
Efforts are needed urgently. The world must produce 40% more food grains to feed its bigger population of over 8 billion by 2030. Although urban Singapore has no significant agricultural industry, its high-tech molecular biology research has helped generate new knowledge for rice farming. An effort that'll go a long way to enhance regional collaboration and improve food security for its people.
Singapore is completely dependent on imported rice from the region. Hence, it's of strategic importance for Singapore to contribute to regional capacity building and to ensure sustained rice production in the region for the long term.
Researchers at the National University of Singapore, or NUS, have been collaborating with the International Rice Research Institute since 2012. They've made a few remarkable breakthroughs in the molecular marker assisted breeding method. This method helps to speed up the development of new varieties of rice to about 2 years, which is less than half the time taken by the conventional method.
Marker-assisted breeding provides the tools for the plant breeder to be able to select for the multiple genetic markers in the hundreds of plants arising from a specific cross. The breeder can easily and quickly select the correct seedlings with all the desired genetic markers. These seedlings should have the predicted beneficial traits in them.
One of the discoveries made by the NUS team is the gene that controls seedling growth rate. This improves the direct seeding farming method. Rice seedlings will grow quicker than weeds, and grains will be produced faster by about a week. It also saves labor compared to the traditional Asian way of rice cultivation, where rice seedlings are transplanted into ploughed fields. The team also discovered genes that control the growth of efficient water-absorbing root systems. Such plants can survive better in drier conditions, making them climate resilient.
Our findings will contribute towards improved food production in the region during the coming decades.
With no natural resources, Singapore has to constantly push its limits through science and technology. Water is so precious that 2/3 of its land surface have been set aside as catchment areas. And scientists here are helping to keep the water safe. Since 2012, Professor Darren Yeo and Dr. Maxine Mao have been investigating Cyanobacteria, also known as blue-green algae. While they are a natural part of the reservoir's ecosystem, some strains are known to produce toxins that make water unsafe. This spurs the interest of researchers in many countries. Singapore's study is among the first in the tropics.
Cyanobacteria are in the reservoirs, but water treatment will usually clear the cyanobacteria and clear the toxins. So what we drink or whatever goes to our taps and all that doesn't have all this. So then why do we still study the toxins, right? It's a sort of a pre-treatment precaution. So the water treatment will ultimately get rid of everything, but this, if the raw water that is treated doesn't even have toxin in the first place, that makes it even better.
Cyanobacteria grow naturally in fresh water and multiply rapidly in warm conditions or when they've enough nutrients. But these algae are difficult to culture in the lab, making Professor Yeo's study challenging.
Another issue is that a lot of these cyanobacteria, right, they're very, very difficult to tell apart. They look very, very similar under the microscope. So you need a lot of experience and trained eye to try to separate them.
The two biological scientists painstakingly studied the growth patterns of tropical cyanobacteria for more than 3 years.
I carried out experiments varying the temperature, light and nutrients to find out how was the growth affected by these factors and how was the toxin production affected also by these various factors.
We thought, you increase the temperature, the growth will get better. The cyanobacteria will grow faster, but it didn't actually. So that was quite surprising. But the toxin production did increase a little when we increased the temperature.
Professor Yeo and Dr. Mao have completed their project recently. Their findings will not only help fill an important knowledge gap in the world, but also facilitate better management of reservoir water in Singapore.
Generally, some of these patterns are useful to help PUB when they monitor their own environmental parameters in the field, in the reservoirs. This will help them to, know whether the temperature or the nutrient levels are at a level that might encourage growth of cyanobacteria or that might discourage growth of cyanobacteria.
Besides enhancing water and food security, researchers in Singapore's tertiary institutions are also creating more efficient clean energy. Energy is the lifeblood of modern cities. And Singapore is blessed with an abundance, naturally. Being near the equator, the island receives an average of 4 to 9 hours of sunshine each day, depending on the weather. Harvesting this cheap and infinite energy and relying less on natural gas is its commitment to a sustainable future. The demand for solar panels here is set to rise as the island plans to harness sun power to meet 10% of its total energy needs by 2030. But it'll not be an easy task for land-scarce Singapore.
The best spot is always the rooftops. Unfortunately, in Singapore, many rooftops are too cluttered. They have not been built to host a solar system. They host water tanks and air conditioning equipment, but they are not flat and not well suited for solar systems. So we have to be a bit more innovative. We put them on warehouses, factories, floating systems, on water reservoirs, and novel solutions like that.
Leading the way in solar technology research is the Solar Energy Research Institute of Singapore, or SERIS, at NUS. The institute has a multidisciplinary team of over 100 scientists, engineers and architects. Among them is this R&D team, researching on multi-crystalline silicon solar cells, the most widely used globally now.
It's an amazing material, and silicon is cheap, readily abundant in the Earth's crust, and it can be produced in huge volumes.
Compared to monocrystalline solar cells, multicrystalline solar cells are cheaper to produce and can perform nearly as well. But Dr. Joel Lee, who heads Ceres's multicrystalline silicon solar cells group, wants to push the boundaries even further.
We do process optimizations to improve efficiencies, and we design new processing techniques to lower costs and improve efficiencies. With higher efficiencies, consumers can get more power from a given rooftop. Higher efficiencies is particularly good for urban environment like Singapore, where land is scarce.
To turn research into real products, the Ceres team works closely with industry leaders such as REC Solar from Norway. Together, they've developed more efficient solar cells that can convert 17% of the sunlight hitting the panels into electricity. These solar panels are now exported to Europe and the United States.
Another thing, closer at home, we have contributed significantly to the solarization of Singapore. 10 years ago, there was no solar in Singapore.
Ceres has helped to boost the adoption of solar panels by 60% in 2015 against the previous year. By now, the installation has passed the 50 megawatt mark in Singapore. At the same time, Ceres is playing an active role in setting up industry standards in the region.
Standards are very important for solar panels and solar systems because they are an electric power plant. We have established here at Ceres an Asian PV Quality Assurance Center where we provide services to industry to ensure the systems that are installed in Singapore and beyond are safe and operate as expected. This is an important part of our work, and it will help to contribute that the deployment of solar system accelerates further in Singapore and the region.
At the Energy Research Institute of Nanyang Technological University, or NTU, researchers are exploring innovative new materials beyond silicon. One of which is Perovskite, a promising material that could hold the key to creating high-efficiency, inexpensive solar cells. Flexibility in form and function is what makes scientists excited over it.
Landscape like Singapore, where every building is completely covered with glass, it opens up the new possibility that solar cells now, in addition to the rooftop, can also be covered all over the facade of the building. The main advantages of perovskite solar cells is they can be processed at a much lower temperature, so the process can be cheaper, the process is simpler. The main challenge of the perovskite solar cells is this material was first discovered suitable for solar cells only 3 years ago. So although there is a lot of understanding of the material, there isn't enough understanding of the applications.
Despite the challenges, NTU researchers have made some inroads in understanding the material and its applications.
These solar cells also had the possibility of light emission. So that opens up the possibility of using them in light-emitting devices as well as in lasers.
Back at NUS, researchers from the Departments of Chemistry and Physics are using another novel material to develop the next generation solar cells. These organic solar cells are made of molecules containing carbon, nitrogen and oxygen formed through chemistry. One of the researchers is PhD student Cindy Tang, who is improving the performance of these cells.
The main challenge faced by organic solar cells is its lower efficiency compared to traditional silicon solar cells. My biggest breakthrough is developing new materials that allows charges to be collected more efficiently. So this has increased the efficiency of organic solar cells, and some companies have expressed interest in our technologies.
Organic solar cells are already being tested at Seletar in northeast Singapore. These solar cells are environmentally friendly and they generate electricity with zero emission.
Compared to traditional silicon solar cells, organic solar cells are flexible, and this allows them to be integrated onto curved surfaces of the buildings. Also, organic solar cells are semi-transparent as opposed to opaque silicon solar cells. So this allows them to be made onto windows of buildings that will then allow a good amount of sunlight to pass into the building. The third advantage of organic solar cells is that they can be used to power wearable electronics, such as being integrated onto clothing or watches.
Although organic and Perovskite solar cells are emerging technologies, they have the potential to provide clean energy efficiently. Besides the search for green solutions, researchers from tertiary institutions are also paving the way for Singapore to become a smart city. Road overcrowding is a bugbear Singapore wants to avoid at all cost. Currently, 12% of its 700 square kilometre land is used for roads. That's about 17 times the size of Sentosa Island. Managing traffic flow is now a key priority for the land-scarce country. In recent years, researchers here have been studying sustainable transportation systems. And all their paths lead to Singapore's vision of becoming a smart city.
So I've been working in robotics for a long time, and autonomous vehicle is a robotic car. Among all the different applications of robotics, I think this is perhaps one of the most exciting because it is one that has a tremendous impact in the quality of life of everybody.
But Singaporeans love their cars. In 2015, more than 57,000 new cars were registered, adding to the nearly 1 million vehicles already on the roads. To ease congestion and eliminate pollution, the city-state is turning to this promising solution, the driverless car.
A driverless car means a computer is driving the car in the most efficient way. No fast acceleration, no braking suddenly, all smooth. That results in fuel efficiency and less pollution in the environment.
After 3 years of research, the NUS team has made one key breakthrough. The researchers have developed a software for the car's sensor device called LiDAR, which stands for Light Detection and Ranging. This software helps to generate a three-dimensional map that enables the driverless car to navigate safely in a densely built-up city like Singapore.
Our car do not rely on global positioning systems. So we use our LiDAR, our laser sensor, to provide localization. Our sensors not only know there is a pedestrian or car, can only know the speed and direction of this.
The team has successfully tested their driverless car on public roads at One North, a 200-hectare business park developed by JTC Corporation. While the driverless cars are still in a test phase, Professor Marcelo Ang is confident that they'll bring Singapore closer to its smart city ambitions.
With a good planning algorithms on how to move, the actions will be repeatable, consistent, doesn't get tired, reliable, so accidents will be reduced. So because of that, the environment will be less congestion, less stress, and people will be happier.
While powering these driverless cars with electricity is environmentally friendly, keeping the batteries charged could be a challenge. Over at NTU's Energy Research Institute, researchers are developing ways to charge these electric vehicles quickly, safely, and without the hassle of wires. Electromagnetic coils are kept in the ground and in the vehicle, where it's connected to the batteries. When the vehicle stands over the coil embedded in the ground, power starts to transfer to the batteries. All done wirelessly, without any plug and socket.
The benefits of wireless charging is convenience. Very fast charge of vehicles will help to make these vehicles more efficient, and not just the vehicle more efficient, but also the transport solution more efficient.
Vehicle aside, transportation of the future must be able to help people get to where they want quickly and cost-effectively. The Department of Civil and Environmental Engineering at NUS is exploring just that. An intelligent transport system that connects passengers and vehicles. The concept of a car-light society is emerging.
We like to explore the possibility if we can remove the car ownership from the whole pictures. In the future in Singapore, other than having a reliable, convenient public transportations, we are able to make our personalized mobility environment to be heavily utilized by the autonomous vehicle. I think this is something going to change our overall city environment.
From understanding passenger movement to traffic management, big data is becoming increasingly important in planning a smart city holistically. To unlock solutions, science and engineering have to come together with two important subjects, mathematics and computing.
With big data, traffic operators can extract useful information to understand users' behaviors. From there, they can build models to perform various simulations to understand the effects of various policies and incentives. In all these tasks, mathematics is used in the design, analysis, as well as finding the solutions of the models in order to support better decision-making.
Mathematics and computing play a key role in transforming big data to smart data. An example is the probability of default model designed by NUS's Risk Management Institute in 2006. This produces credit risk measures for more than 60,000 listed firms in over 100 countries.
Another example is mathematics and big data can be applied in the healthcare industries. Healthcare data can be mined to provide insights in the systems, which may lead to the redesign of some of the processes to achieve shorter waiting time and cost savings. In this way, mathematics and big data can contribute to Singapore's visions of a smart city.
Be it mathematics, computing, engineering or science, researchers here are helping to transform Singapore into a smart and green city. And their inventions are contributing to the global effort towards achieving a sustainable future for all.
Brought to you by the National University of Singapore in celebration of SG50.